So today we're going to look at the science behind toric IOLs. Let's begin with the keratometry, which has historically given us the corneal power for calculation of IOL power, but it's based on a lot of assumptions. The first assumption is that it considers the cornea as a single refracting sphere and does not consider the posterior corneal surface. It takes it um, as a function of anterior corneal curvature, and it says that it's related to the posterior curvature relates to the anterior curvature with a constant factor k. Secondly, the refractive index of cornea is an assumed value, what we call Javel's index, and it's around 1.3375. Third thing is that takes corneal thickness as a standard zero point 0.5 millimeters. So we all know that if we want to reach perfection in IOL power calculation, these assumptions have to be replaced by the actuals. And the first step came in 1986 by Dr. Olson et al. In the paper published in BJO. He worked on this second assumption of corneal refractive index, and he gave a formula. I'm not going into the details of the formula. And he said that instead of 1.3375, if we use 1.3315, we can reach the corneal power calculation to a reasonable accuracy, that is within zero point 0.1 diopters. In the same paper, he said corneal thickness is not so much of a problem because even if you double the corneal thickness, it'll affect only the corneal power by zero point 0.1 diopter. But the posterior surface variability, it can really impact in some cases, especially where the cornea is very steep. Even corneal thickness matters if the cornea is very steep. So all these issues become important in certain subset of eyes. In 2000, we all got toric IOLs, and we know that at that point of time, we were able to nail our refractions post cataract surgery in case of spherical IOLs. But as far as toric IOLs were considered, we all knew that we were not nailing it exactly. We were getting surprises very often, and there was residual refractive error after the cataract surgery. So let's try and look at the two surfaces of cornea. We know it has anterior and the posterior surface. The anterior surface acts like a positive lens, and the steep vertical meridian creates, with the rule astigmatism, requiring a positive cylinder to correct the same axis. Whereas the posterior corneal surface acts like a negative lens, and the steep vertical meridian produces an against the rule effect, which kind of compensates 10% of anterior astigmatism. In 2005, we all got the pentacam, and here the exacts could be calculated. We can directly measure both the anterior and the posterior corneal astigmatism using a rotating Scheimpflug camera. Now, in using this tool that we've got, a lot of papers came in JCRS. Ho et al. Calculated the mean keratometric index, the actual mean keratometric index in 2008, compared to the standard keratometric index of 1.3375, he found that it was 1.3281, which was closer to what was given by Olson et al. It did improve our prediction accuracies, and as it was expected. Now, the same group in 2009 said that we cannot neglect the posterior surface, and if we neglect the posterior corneal surface measurements, it can lead to significant deviation in the corneal astigmatism estimation. This was the first time in AJO this paper was published by the same group. And in 2010, they said that as one grows older, ignoring PCA can cause a lot more problem, because in youth, when you're young, the anterior surface, most of us have with the rule astigmatism, and posterior surface has against the rule compensation. But as one grows older, the anterior surface cornea, from which the rule changes to against the rule astigmatism, whereas the posterior corneal astigmatism remains stable. That is, it remains against the rule. Hence, if you're correcting an ATR that is against the rule astigmatism in an elderly, you can land up with residual astigmatism. It's going to underestimate it. Now, this was a very important paper by Robert Koch in 2012, published in JCRS. He gave us the exact value of the posterior corneal astigmatism, which was found to be minus 0.30. He looked at 715 corneas, and he said, if you're looking only at the anterior corneal surface, it can underestimate the corneal astigmatism by an average of 0.22 diopters. I just want to share the slide from my 2014 cataract update at Shankar Nethralaya, second cataract update, I think. And at that time, I presented the results of toric IOLs, and then I did talk about the surprises. You can clearly see a few slides. These are 3 slides that it's not in my hands. I can't explain it. And as I was making the PPT, I saw that in 2015, Savini et al. Had answered that why we were getting all those surprises, and the number 1 influence was the posterior corneal astigmatism. So it's clear that we need to integrate PCA if we want to do toric IOLs. See, if we are doing spherical IOLs, not taking PCA into account is not that much of an issue. But if you're moving to toric intraocular lenses, you need to integrate PCA in the IOL power calculation. You can either estimate it using Baylor nomogram, Barrett toric calculator, or you can calculate it by, if you have those machines like IOL Master 700, where you get the total keratometry, you can actually calculate the PCA. But even if you don't have those machines, you can use the Baylor's nomogram or Barrett's toric calculator, and it can be used to give us the accurate IOL power calculation. And I want to share this interesting 2006 paper from JCRS, which I like to call it a rudimentary Barrett's TK Universal 2, because, this formula by Bozario, Stephen, and Smith et al. It is based on Gaussian optics principle. It incorporates anterior and posterior corneal radii in the pachymetry, and you don't need, and this was actually a data set of 143 eyes that had undergone keratorefractive surgery. They were used to calculate this formula, which was validated on 13 eyes, and it gave an accurate result. I'll end my talk with this food for thought slide and topic of leftover astigmatism. Goggin et al., they say that the measured posterior corneal astigmatism, that is, when you measure it doing refraction in pseudophakic eyes, that appears to be consistently smaller than the calculated. The measured is the one which you measure using the machines, and calculated is the one you calculate in pseudophakic eyes. You try to calculate the posterior corneal astigmatism by using the refraction that gives us the anterior corneal astigmatism, and we have the known power in the IOL. So you can calculate the posterior corneal astigmatism, and that value is supposed to be consistently more than the measured posterior corneal astigmatism. So that means that there is a leftover astigmatism that we don't know from where it's coming. It could be because of the lens tilt, decentration, irregular posterior capsule, or higher order aberrations, but that's something one can look into and research further. So thank you.